Section 1.5 is adding and subtracting real numbers. I can find sums and differences of real numbers. Big ideas here. Any real numbers can be added or subtracted using a number line model or using rules involving absolute value. Subtracting a real number is equivalent to adding its opposite. In example 1, we're going to use a number line model and figure out what each sum is. So in order to do this, we are going to start at 3, our first number. And we're going to add 5, which means we're going to increase by 5. So we count from there, 1, 2, 3, 4, 5. X marks the spot. We get 8. Same idea here. We start at 3, and then we add the opposite of 5. So instead of going towards 5, we go back 5. So back 1, 2, 3, 4, 5. X marks the spot. We get -2. For -3 plus 5, I start at -3, my first value, and I add +5. So I go in the positive direction. Remember, the right arrow takes us towards positive numbers. 5. 1, 2, 3, 4, 5. I get 2. And for D, I start at -3. And negative numbers go to the left. So I'm going to go left 5. X marks the spot, and we get -8. Okay, so number lines work as one way that we can find sums. We want to know what is -8 plus 4 using a number line. So here, I start at my first number, -8. And 4 is positive, so I'm going to go towards positive numbers, towards my positive arrow here. 4 places, 1, 2, 3, 4. And I get -4. So -8 plus 4 equals -4. The absolute value of a number is its distance from 0 on a number line. Absolute value is always non-negative, since distance is always non-negative. Okay, when we go to Enderlin, we go 17 miles. When we come back, we don't come -17. That distance, even though it's in the opposite direction, is still 17 miles, or whatever it happens to be. Okay, distance is always non-negative. So here, the absolute value of 4 is the exact same as the absolute value of -4. Either way, we get 4. So there's a take note on page 31 about adding real numbers. If we have the same sign, we're going to add the absolute values and use the common sign. So whether it's 8 plus 12 to get to 20, or -6 plus -4 to get to -10. So here again, absolute value would be +6, absolute value +4. We add them up, get 10, and give it that common sign. So -10. If we have different signs, we're going to subtract the lesser absolute value from the greater absolute value and use the sign of the number with the greater absolute value. So here we're looking at just the number parts, not the signs. I have a 5 and an 8. Well, 8's bigger, so I'm going to subtract the smaller one, and I get 3. Now I look and see which number part is bigger. Well, 8 is bigger than 5, and 8 has a negative in front of it, so my answer is going to have a negative in front of it. Here I have an 11 and a 13. Well, 13 is bigger than 11, so we subtract and get 2. Now I look back to 13 as my bigger number and see what sign is in front of it. It's a positive, so it's a +2. So if we have the same signs, we find the sum, give the common sign. If we have different signs, we find the difference, and then give the sign of the bigger number. So we can always give the sign of the bigger number, because when we have the same sign, guys, both of them are going to have the same thing. So the bigger number here, 6, for example, is negative, 12 positive, 8 negative, 13 positive. So if we always give the sign of the bigger number, we will be just fine. So to find each sum here, we look, are our signs the same or different? One of them's negative, one of them's positive. So we have different signs. So we find the difference and subtract. And again, we're taking our absolute value, or just our number part. So I have a 12 and a 7. And because I have different signs, I'm going to find the difference and subtract to get 5. Now, we look back at our original bigger number here, 12. And since that's negative, so is our answer. Okay, in B, do I have same signs or different? I have a negative and a negative. So I have the same signs, so I find the sum. I take my number parts, again my absolute values give me just my number values without our signs, and I find the sum. I add them up to get 20, and then I look back at what that sign is or check my bigger number. It's negative, so is my answer. Same idea here in C. I have a negative and a positive, so I have different signs, so I find the difference and subtract. I take my number parts, which here's a 9.5 and here's a 4.8, and I subtract bigger minus smaller. Guys, it's always bigger minus smaller when we're subtracting. Subtract here, I get 4.7. Now, we always give the sign of the bigger number. So if we look at 9.5, that's positive, so my answer is going to be positive. And in D here, same idea. I have a positive and a negative, so I have different signs, which means I find the difference, and I'm going to subtract. So I take just my number parts here, my absolute values, and I take bigger minus smaller. When we have fractions, remember we have to have a common denominator. Our common denominator here between 6 and 4 is going to be 12 is our least common denominator. We could have used 24, but then we'll have to reduce at the end. So 12. So to go from 6 to 12, I got to multiply by 2, and if I change the denominator, I have to change the numerator accordingly. To go from 4 to 12, I have to multiply by 3. And if I change the denominator, I have to change the numerator the same way. Now that I have a common denominator, I keep my denominator and subtract my numerator. 10 minus 9 gives me 1. And then we check back at our bigger number. 5, 6 is bigger. It's negative, so our answer is going to be negative. Negative 1/12. Now, feel free to pause here and give these a try if you'd like. Finding each sum, I'm going to take the absolute value, or just my number parts here, and I have a 16 and an 8. Keep in mind my signs were both negative, so they're the same signs. I'm going to find the sum and add these up, which takes me to 24. Now I look at my common sign, or what's the sign of my bigger number? Either way, it's negative, and I get negative 24. In B, I have one negative and one positive. My signs are different, so I find the difference and subtract. Again, we're taking just the number parts, so the absolute value of negative 11 is 11, and 9 is 9. Bigger minus smaller, always, gives me 2. Now we look at our values. 11 is our bigger number, bigger absolute value, so we check it. That's negative. Our answer is going to be negative. Trying C here, I have a 9 that's positive and an 11 that's negative. So since I have different signs, I'm going to find the difference and subtract. Again, we want just the absolute values, just the number parts here, so just the 11. And 11 is bigger, so it always goes first. Bigger minus smaller when we have different signs, which gives me 2. I look at my bigger number, it's negative, so my answer is going to be negative. And in D, I have a negative and a negative, so I have the same signs. I find the sum and add them up. So again, just our number parts, our absolute values. We add those up to get 8, and then we check. Since both of our signs are negative, or we can check that bigger number and see that it's negative, we know our final answer is going to be negative. Two numbers are opposite if they are the same distance from 0 on a number line, but in opposite direction. A number and its opposite are called additive inverses. To find the sum of a number and its opposite, we use the inverse property of addition. So if we look at the take note on page 32, it tells us that if we add a number and its opposite, we're going to get to 0. That's our inverse property of addition. Now, if we look at the subtracting real numbers, it tells us that to subtract a real number, we add its opposite. So instead of taking 3 minus 5, for example, we're going to take 3 plus negative 5 and get to the same spot. So the first thing we're going to do is anytime we see subtraction, we're going to change it to adding the opposite of whatever follows. So instead of -8 minus -13, we're going to change it to adding the opposite. The opposite of -13 is +13. So I'm going to rewrite it as -8 plus 13. And now we treat it just like we did on the last slide. So I have a negative and a positive. I have different signs. So I find the difference. I have different signs, subtracting, take my absolute values or my number parts. I get 5, 13's bigger, so we check back to our addition problem. We check back right here. And 13 is positive, so I get a +5. Same idea here in B. I change from subtraction to adding, and I take the opposite of what follows. So I'm going to have 3.5 change from subtraction to adding, and take the opposite of what follows. So instead of having 12.4, I'm going to have a -12.4. Now, I have one positive and one negative, which are different signs. So I find the difference and subtract. Again, it's just our number part. So 3.5. And the absolute value of -12.4 is +12.4. Now I subtract because my signs are different, and I get 8.9. We look back and see that 12.4 was negative, so our answer is negative. In C here, I change from subtraction to adding the opposite. So I have 9. Instead of subtraction, I change to addition, and instead of subtracting 9, I'm going to add the opposite, -9. So I have one positive and one negative. So I have different signs. I'm going to find the difference and subtract. Absolute value of 9 is 9. Absolute value of -9 is 9. When I subtract, I get 0. And that's one of our properties we talked about today, our inverse property of addition. A number and its opposite add to 0. Now, feel free to pause and give it a try here. First thing I'm going to do is change from subtraction to adding the opposite. So I'm going to change it from 4.8 minus to plus, and instead of being -8.7, I'm going to change it to +8.7. Now I have the same signs, so I find the sum and add them up. Absolute values here, 8.7 plus 4.8 is going to give me 13.5. We can apply the properties of real numbers from section 1.4 to both positive and negative numbers. So, a reef explorer dives 25 feet to photograph brain coral and then rises 16 feet to travel over a ridge before diving 47 feet to survey the base of the reef. Then the diver rises 29 feet to see an underwater cavern. What is the location of the cavern in relation to sea level? So, before this reef explorer dives, it's at 0 feet. It's at sea level. It dives, which means it goes down 25 feet. Then it rises, which means it increases 16 feet. And then it dives again 47 feet. And remember, when it dives, it subtracts. Then the diver rises 29 feet. So we add 29. We want to know, where does this end up? Well, we add or subtract at the same time from left to right. So I'm going to change this to adding the opposite. 0 plus -25 gives me -25. Now I'm going to add 16. Different signs, so we subtract our absolute values, give it the sign of the bigger number, -9. Then I bring down my -47. I change subtraction to adding the opposite. Both are negative, so we're going to find the sum. It's going to give me 56. I look, 47's bigger, it's negative. Then I add 29. Different signs, so I'm going to subtract 56 minus 29, and I'm going to get to 27. 56 was negative, so my answer is negative. So -27 feet, or 27 feet below sea level.